Today, I'm going to teach you about the structure of the hair and how the hair grows. So we can only see what's going on outside of the scalp, but there's a whole other world going on underneath. So let's start with what we can see. Above the scalp, we can see this beautiful hair. Each individual hair strand is composed of three parts. There's a cuticle, there's a cortex, and there's a medulla. The cuticle is the outside layer of the hair. It has transparent layers so they're completely clear and see-through. These layers protect the inner parts of the hair. It's like little tiny layers or scales that rest on top of the hair. And a healthy cuticle layer will have all of those little layers laying nice and flat and nice and smooth. If the hair becomes damaged, that cuticle will actually raise and lift up, causing the hair to look dull and kind of frizzy, and actually allowing even more damage to happen to the hair. Once we move past the cuticle, we can move into the cortex. Now the cortex is where all of the excitement happens. This is where the bonds of the hair are that allow us to change its shape, change how it goes when it's wet, when it's dry, when we use chemicals. There's all of these things that happen within the cortex and these bonds. The other cool thing that's in your cortex is your melanin or your pigment. This is where we can go to actually color your hair. Your natural color is your natural melanin or your natural pigment. When we go to color your hair, we're going to go through the cuticle into the cortex, and we're going to rearrange all of those melanin pigments to give you a new color. The last and final part of that outside structure is the medulla. Now the medulla we don't talk too much about because honestly, not everybody even has a medulla anyway. Usually men's beards have medullas. People with super coarse hair may have one. Other than that, we really don't need to worry about it. It doesn't play any function in anything that we're going to do to the hair. Now let's talk about the parts that you can't see. Below the surface of your scalp, or the epidermis, is this whole other world of stuff going on, and that's where your hair originates. I've talked to clients and different people, and they think that your hair grows from the ends. This is not the case. Your hair grows from within your head, and it grows out that way. So when we get below the surface of the scalp, you're going to see a follicle or a pocket that's in your skin, and this little pocket goes right down underneath the epidermal layer. This follicle is what's going to hold your hair root. The follicle is going to hold the hair root in place. At the bottom of the hair root is the bulb, and the bulb is that little white ball that's on the end of your hair. So if you've ever ripped a hair out of your head and you get this little white bulb on the end of it, that's what it is. It's your hair bulb. The hair bulb actually fits into what's called the dermal papilla. The dermal papilla is what we refer to as the mom or the mother of the hair, because the dermal papilla is what supplies all of the blood and nutrients to the hair itself. So the bulb kind of sits into that dermal papilla. It supplies all of the nutrients and everything that the hair is going to need. Now attached to the follicle are a couple of different things. The first thing are the sebaceous glands. The sebaceous glands contain a substance called sebum, and the sebum is like the oil that we can get on our skin. It helps to lubricate our skin and our hair. Sebum is very important to keep our skin and our hair very healthy. Normal oil production is very crucial to having healthy hair and skin. Now you may have heard some people refer to overactive sebaceous glands or underactive sebaceous glands, and that basically just means that if your sebaceous glands are overactive, they're producing too much sebum, and you can have really oily skin and really oily hair. Underactive sebaceous glands is just the opposite. You can have extremely dry skin and extremely dry hair. So this is all linked to that sebaceous gland. The other part that's attached to the hair called the erector pili muscle. This is the fun one because this is the muscle that contracts when you get cold or you're emotional, and we all know it to be called goosebumps. So when you get goosebumps, it's actually your erector pili muscle that is contracting and causing your hair follicle. It kind of contracts and squeezes the follicle and causes your hair to stand up on end. Now, how does all this hair start in the first place? Deep within the follicles of our hair are cells. These cells, as they mature, they travel up the follicle and they fill up with a fibrous substance called keratin. Once they fill up with this keratin protein, they keep traveling up, but then they lose their nucleus and it dies. So then what you're left with is this fibrous protein, fiber. This is your hair. And as that emerges from the scalp, then you have your hair. This whole process of these cells maturing and filling with keratin is called keratinization. Hair proteins are long chains of amino acids. Amino acids are joined together by peptide bonds. The difference with our hair protein is it's not just a straight chain, it's actually a helix, or kind of like a spiral that happens. So our hair protein actually has a little bit of a different shape than a regular polypeptide chain. The next thing that we need to look at are the side bonds that are located within the hair. These side bonds are where all of the action happens. So let's look at the 3 side bonds that we're going to be dealing with in the hair. The first type of side bond is called the hydrogen bond. Hydrogen bonds located in the hair are very weak physical side bonds. These bonds break super easy. All you have to do is wet the hair and they break. But how you reform them is you dry them or you apply heat. So this is why when you wash your hair and you wet it all down, it goes flat or it goes back to its natural state. Then when you blow dry it, you curl it, you apply heat, you can actually transform it and make something else. It's the hydrogen bonds that make this possible. The next type of bond are called salt bonds. Salt bonds are also very weak physical side bonds. The difference is they actually break when there's a change in the pH. When we color the hair, we have to actually raise the alkalinity of the hair. We're raising the pH of the hair so that we can open the cuticle and allow color to go in. So the salt bonds are breaking. The salt bonds will reform when the pH comes back to normal. Disulfide bonds are the strong chemical bonds that are within our cortex. These bonds break when we do services like perms and chemical relaxers. Perms and chemical relaxers will break disulfide bonds, but then they also are kind enough to put them back together again. Hydroxide relaxers, on the other hand, are not so nice. Hydroxide relaxers will actually break disulfide bonds. Then they completely change their identity into a lanthanide bond. They can never be a disulfide bond again. This is sad for the disulfide bonds. This means that hair will usually never hold a curl after it's had a hydroxide relaxer. Now that you understand the inner workings of the hair, the different structures, the bonds, how they break and how they're put back together again, you're going to be able to take this information and be more confident when you're performing services in the salon. Thank you for watching and have a great hair day.